Hello, anatomy and physiology class. Today, we're going to kind of take a step back from talking about sarcomeres and contractions and kind of look at the muscle as a whole and what's happening when we exercise, when we work out, or just general usage of a muscle. So, basically, muscles can work one of two ways. They can do aerobic respiration, which is where we have oxygen and we're making lots of energy, or we can work anaerobically. In anaerobic respiration, you don't have enough oxygen. So if I go on a run, I'm going to start using aerobic respiration. But if I keep running, sooner or later, my body isn't going to be able to keep up with the demands of the muscle, and there's not going to be enough oxygen. At that point, the muscle is going to switch over and start using anaerobic respiration. The downside of this is you don't produce as much energy, but you also produce lactic acid. And lactic acid is that chemical that gets inside our muscles that gives us that kind of pain, sore, kind of achy feeling. And although that doesn't feel good, it actually serves a very important purpose in the muscle in that it prevents you from working out too hard. It tells you to stop so you don't cause a lot of muscle damage. Um, a goal, a lot of times when people lift or work out, is to cause little muscle tears so that when the muscle gets repaired, it gets bigger and stronger. But we don't want to cause really big tears because that would be a detriment to our muscles. So the lactic acid causes that pain and that discomfort, so you stop working out. Once you get done, though, we've got to be able to get rid of lactic acid. And basically, you can get rid of lactic acid by getting oxygen into the muscle. Then our body is able to turn lactic acid back to something called pyruvic acid, which we can use to make ATP. But you might notice after a hard workout, especially, you might be sore for a day or two after. And that process of kind of repairing the muscle and cleaning up the lactic acid can take a little while. It's not kind of an immediate fix. So let's look at what happens inside the muscle. So a muscle cell gets these tiny little um, points of tears inside of them. The muscle can't actually repair itself. So little cells called satellite cells are kind of all around the muscle fiber. And when the muscle gets damaged, it sends up a little signal, help me, I'm damaged. And the satellite cells are going to come to that spot. They're going to divide rapidly and they're going to kind of fill in that hole where that damage has happened. The nice thing about that is that that's one of the ways we can increase our muscle width. The difference between my bicep and Dwayne The Rock Johnson's bicep is that my muscle fibers are only this big around, his are this big around, right? That's how we increase our strength. Is we don't get more muscle cells, we just increase the diameter of muscle cells. So here's just kind of a picture that shows you that process of that. We have a damaged muscle fiber. It activates this satellite cell, which makes a bunch of extra cells, and they kind of go in and they fill in this gap. Okay. They can do a couple different things. They can become the myosin and actin cells inside of the muscle. They can fuse with it, and their nucleus can become part of the muscle cell, or they can increase the width of the muscle cell. So satellite cells can do any of these things, and they're the main thing that's going to help fix our muscles. Okay. Um, Outside of that, we have two different types of contractions, isotonic and isometric. Iso means same. So isotonic literally means same strength. So if I'm taking a 10-pound weight and I'm doing bicep curls, that movement, that muscle is shortening, but it's exerting the same amount of strength every single time I do that curl. Isometric means same length. So if I push my hands against each other, I can push them kind of gently, and I can push them harder and harder and harder, and I can feel my muscles working harder. There's no movement happening. My arms are kind of staying just like this. Okay, doing a plank, doing wall sits, as you see there, pushing against the door. These are all examples of isometric contractions. And isometric and isotonic can be used to kind of condition, strengthen, and work on our muscle strength. And they shouldn't be used by themselves. Using them together is a good thing to do for our muscles. So, two big types of muscle contractions, isotonic and isometric. Okay. The last thing we want to talk about today is the difference between fast and slow fibers. Everybody has both fast and slow fibers inside the body, but they might have different quantities of fast versus slow fibers. So if you look at a really good jumper or a really fast sprinter like Usain Bolt, that person's going to have more fast fibers than your average person.